Ba-da-dum-bum. Welcome everybody to episode 45 of the Swift and SwiftUI Learnalong. This is for the uninitiated, quick intro. This is what I've coined fly on the wall learning, so no direct interaction, and this isn't me regurgitating info I already know. It's literal raw learning as I go. So we've been working our way through this Big Nerd Ranch guide on Swift, the general purpose programming language. So we've covered every aspect of the language just to give you a quick look. Great book, by the way. So if you don't feel like watching the entire stream, all of this has been streamed, by the way. So the entire contents of this book, effectively how it goes, I read the book to you and to myself. Work on the projects, or work on the, well, there are some projects, but work on the coding challenges, the examples they give us, and we just step through all of these things. So throughout the 45 episodes, today we'll finish this book, and that'll be, in totality, this 818 behemoth of a book, but a great book. So yeah, Big Nerd Ranch Guide. Great franchise of books, period. I mean, they make other books, so I mean, it's not just this one, but yeah, this is a great pickup. If you need a book, just make sure you get if you buy a physical copy, make sure it's the latest edition. This is already the 7th. I think there's 9 of this one. And Swift 6 is coming out this September. So if you don't want to get a book that doesn't effectively miss out on anything, make sure you get a book that covers up to at least 5.10. Yeah, because that's effectively what 6.0 is, except some of the defaults will be different, but all the features are there. So just that's a quick aside. But anyway, so we're going through this book. We're going to finish it today. We've covered all of these aspects of the programming language, and it's been very impressive, got to admit. So my previous experience has been a ton of SQL, working in industry for an ERP reseller, working in that space, and then also some Golang. And yeah, Swift is, I mean, I've never written C++. I've read a lot about it just because I just think it's interesting. And there's a lot of rich history there. But it really seems, from a feature standpoint, very, very feature rich, just like C++. And most of the things that we've encountered, even though it can be a little, I'll say, I don't know if frustrating is the right word, overwhelming is probably a better word. Even though some of the stuff has been overwhelming, I'll say, by the end of it, with a little bit of help from ChatGPT with additional explanations, this has been a very good learning experience, I would say. So all in all, happy with the choice that I made. But anyway, so we're going to finish the book today, then we're going to roll into a SwiftUI specific course. So right now, this very last chapter is actually covering SwiftUI, so I'm stepping through it. But if none of it's making sense, don't worry, because we're about to do a whole dedicated course on it anyway. Because frankly, I mean, for me, it's a little jarring because we're going from the switch from general purpose to a Swift framework. And so with the initial, everything leading up to chapter 28, we were able to see the underlying implementation, but now with SwiftUI, it's not open source, so we only see the interface now. So a lot of the deep dives and the questions we could get answered before, we can't do that now, so it's more just like do this, like learn the API, basically, is all that is. Which is fine, but it's just a change of pace, right? So we're going to finish the example that we've been working on in the simulator and then roll into that course. But I might show you a few of the tools that I bought early on for SwiftUI just to fill out the stream, because I don't know that it just depends. We'll see how I'm feeling in a few hours. But yeah, I think that might be handy too, just to take inventory, in effect, on the tools that I bought, because I bought a few and now I'm having trouble remembering, but they're all on this Mac, so of course we're going to find them. But I want to see how effective some of them are after learning a little bit more about the language. So we're going to do that today, and then moving forward for the next few, who knows how long it'll last, maybe I'm going to guess a week or two, the SwiftUI course. After we're done doing that, then we're going to do some schema design. So I'm learning all of this stuff in an effort to, I started a company and I want to build my first product in Swift, using Swift, and it's going to be a iPad/iOS application. So obviously it was a good choice for that purpose. So we're going to build, or we'll work on some of the SQL schema design for the local application. So for the SQLite portion of it, that'll be local on device. And we'll also do some REST API design, maybe some, I might try using GraphQL. I think that would be a cool application to use it in. I never really got to dig too far into that, but it seems meaningful, or it looks effective enough. I don't know. Yeah, it's just something I want to check out. So we probably will do it in GraphQL, honestly. But anyway, that's the plan, and then that won't take long, so we'll probably spend 2 days or so on the design, just putting pen to paper some of the ideas, structure and all that. And then after that, we're going to roll back into another Big Nerd Ranch Guide book that will focus on Apple's APIs, the Metals and iOS, macOS, all of the APIs for their actual platforms. We're going to step through a book that details that, as opposed to the deep dive we're doing now into Swift itself. And then once we're done there, that's going to be the full gambit in terms of the APIs we have to work with within the Apple ecosystem, the Swift language, and then the general basis for the design of the application. And from there, we'll just start building it. So if that sounds cool, stick around. If not, get the hell out. And otherwise, let's pick back up where we left off yesterday, which was, we had just gotten this is our simulator, building a little to-do app, and we got it to the point where we can now give it input, but the add button still isn't quite doing anything yet. So far we've just added this sample data. So this is what the existing task will look like, right? A place to accept user input. We added this help text, so that little italic gray text when nothing's in there. We added this feature to disable add task when it's empty, because you don't want to add an empty task. And once we start typing something, we see it become enabled. So that's as far as we got. Still does nothing, and so now that's where we're picking it up. Okay, so tap into the text field, noticing the add. Yeah, okay, that's the right spot. Okay, next, tap the add task button. It just sits there. Why isn't the new task being added to the list? Interlude. Troubleshooting with property observers. Adding a new task silently fails. No errors produced on screen or in the console. Did the button fail to add the new task to the task store, or did the list fail to update and show the new task? To find out, add a property observer to the task array in the task store to find out every time it changes. Okay. So task store.swift, where's that at? Task store. Underneath our private setter here. Okay. Property observer. So we're adding a trailing closure to this property. And the did set was anytime we affect this property, this will run after, I think. I gotta look it up. Something like that, something along those lines. But I know they had a little list in the book itself, so hopefully we can just find it. Did set. Mm, actually, I wonder if they have a. Oh, duh, of course they do. The index did. Did set. There we go. Oh, same page. Okay. You can observe changes to a property in one of two ways: when a property is about to change via will set, when a property did change via did set. Okay, well, there you go. Yeah, so you can observe changes to a property when a property is about to change and when it did change. That's interesting. Okay, so we're using the one that applies after the fact. So it changes and then we observe that through some action. Okay, let me go back. Okay, so we add the did set and then this hashtag text here. We learned our compiler control statements. I think that's something like that. Warning. And the warning is a similar to a to-do, like in a comment. See how it kind of formats like that? Except when we do the warning, each time that we build the app, the compiler will send this to the log. So it's a bit more, I guess, obtuse in the way it tells you there's something still to be done. But outside of that, there's no real effect on behavior. So when I'm done with it, remove this when I'm done with it. Okay. Print. There are now escape character string interpolation. So we're pulling in the number of tasks. There are now weird. Okay. It just seems like that wouldn't read like it makes sense, but maybe it will. Because that would be, there are now, 5. And then what? Because this will be, what is task? It's just an array, so we're going to... Oh well, doesn't matter. We'll see soon enough. Build and run again and try adding a task titled new task. Watch your console output. Okay, so let me pull this up. Console output is bottom right hand corner. Command R. Okay. Oops. Oh, this is what we got. There are now 3. Oh, I see, because the first pulls in Todoodle task. Okay, so there are now 3. So we get the... I know that's small, so I'll just describe it to you. So we get the full array, we get the string, we get this part. There are now, and the count that it pulled in is 3. And then it prints the array in this slot here of all the tasks. So that's what this is, todoodle.task. And then we get the properties for each one, which we added the ID. So that's that UUID that we wanted generated. So that's working. We get the title of the task. First one is add features. Second one, fix bugs. And the third, ship it. Okay. Where did the build and run again? Try adding a task title, new task. Watch your console output. Okay. New task. Okay. So the output is there are now 4. So it says that it added it, but we don't see that reflected on screen. But yeah, it did work. So we have a new record here. This is the 4th one here that we didn't have previously. Okay. There is your new task. So you can roll out the bottom. Wait. So you can roll out the button and the task store as the source of the problem. Meaning the button's working because it's sending it, and the task store because it's capturing it. That means the list is not updating when the task store does. Right. You will fix this shortly by changing the task store to publish its updates in a way the list can observe, so that the list knows to update as well. Cool. You learned what you came here for, so you can remove the property observer. Oh, okay. Let me save that. That's handy, yeah. I like that. So I can get rid of it now since we know that part is working. Oh, this whole thing, yeah. Wait, I always do this, damn it. Okay, just these 2. Task equal. Damn it, what did I do to this thing? This is task store. I'll just control Z it. At least, okay, good. It remembers all that. Okay, there we go. All right, so now, where were we? Right, you learned what you came here for, so you can remove the property observer. Adding temporary property observers to properties or local variables is a great way to discover whether values are changing when and how you expect them to. I thought there was a way to, like, similar to the, maybe we'll look at that at the end of the stream too, but I thought the whole point was to have it in this bottom left-hand corner to see the variables just like you can in a playground. Here. Let's see what this does. Debug hierarchy. Ooh, look at that. What is this? Okay, I'm going to resist the allure of looking at all this stuff. Yeah, that looks handy. Hopefully they show us that, but if not, I'm sure we'll dig into it in the next book. Either way, because that should focus more on Xcode and debugging in general. Okay, so cleaning up after yourself. Did set, okay, we did that. Observing changes to the store. You need a way to invalidate the list when the task store updates. But first, think about what it means for the task store to update. Okay. It would mean the store itself to update. Well, what is the task store? It's our array of tasks and our two methods. The actual instance. So I guess it would just mean to append the new task to the array. Just the task store, not the list necessarily, but the task store. Let's see, task store. The task store type is a relatively simple model class. So this being the topic here. Or wait, is this? Yeah, that's it in its entirety. So from 10 to 22. It does not know how to notify other objects when its task property changes. Teach it how by marking the task property with the @publish property wrapper attribute. Nice. Published. And what is published? A type alias for the combine frameworks type that publishes a property marked with an attribute. Okay. What does that even mean? A type alias for the combined frameworks type that publishes a property. Okay. Type alias for the combined frameworks type for an object. All right, we'll come back to that because I assume we're going to learn about what that combined framework is too. Then it might make more sense. Okay, so we add the attribute. Now, anytime the task property changes, such as by adding or removing a task, the task store instance can publish knowledge of the change to any observing views. Okay, can or will. By declaring conformance to the observable object protocol. Oh wait, I didn't do that part. Class, task store. Observable object. Okay, maybe that'll make more sense. What is this type then? Oh good, also a type alias. A type alias is the combined frameworks type for an object with a publisher that emits before the object is changed. Okay. Task store states its willingness to be observed. And its intent to publish updates of its @publish properties to observers. Okay, so by virtue of conforming to this protocol and using the attribute, the framework just does that for you. That's cool. Okay, the observed object property. Wait. I didn't add that. Oh, I'm up here. Now, anytime the task property changes, such as by adding or removing a task, the task store instance can publish knowledge of the change to any observing views. By declaring conformance to the observable object protocol, task store states its willingness to be observed and its intent to publish updates of its published properties to observers. Any views observing an instance of an observable object conforming class will invalidate themselves. bottle just popped. Will invalidate themselves when the observed instances published properties change their values. So anything referencing this, and because of this conformance in published, will automatically invalidate themselves in terms of the view, so that it gets re-rendered, and then that in turn will make the new data get captured and put on screen. Okay. Yeah. All I can think of when I'm hearing this is React, but it's obviously it's not React, thank goodness, but the way it's described just kind of gives me just traumatized is all. How does a view actually register to observe changes to the task store? Update the task list view to observe its own task store property. Update the task list view. Okay. Task list view to observe its own task store property. And okay. Wow, I mean, that's okay. Hold on, I gotta wash my hands. Why is this so sticky? Good old alcohol swabs. What would the world do without them? We'd have sticky keys for one. Just be gentle now, don't be too rough with it. There you go, buddy. It's one nice thing about columnar keys, easy to clean. This will be so much better. Yeah, the thumbs. And YouTube. All right, OCD tamed. Now we can get back to it. Okay. Oh, observed object. Yeah. Well, I can't really say too much, but in my head, I'm just always a little leery of things that have the appearance of being so simple. Like, hey, observed object. And what do we put on the other one? Task store. Yeah, so we publish it. or mark it as observable, mark the thing we want to publish, and then on the other side, declare what the observed object is. What? That's awesome. It's awesome. It's just, it's always, I'll say in the JavaScript world, I've always been duped when it appears this easy. And you go out and try to write something, and it's like a million different caveats to what you can build with, that design. And then before you know it, 2 structures in, you got to break out and use vanilla JavaScript. So, but I'll reserve judgment. Okay, the observed object property wrapper sets up the subscription to the published properties. The observed property wrapper sets up the subscription to the @published properties of an observable object. The observed object property wrapper. So this dilly sets up the subscription to the published properties of an observable object conforming class. Yeah, okay. When the @published properties update, the owning view, which is taskless view, will invalidate itself just as it would with changes to a state property. Okay. Which did we, I think we did, yeah, it's right here, state. Which I already forgot what that does, but if we do command click, right, yeah. So this is, creates a state property that stores an initial wrapped value. You don't call this initialize directly, instead SwiftUI calls it for you when you declare a property with the @state attribute and provide an initial value. Oh, cool. Okay, yeah, all right. Okay, so now test this view here. Invalidate, just as it would with changes to the state property. Okay. Whoops. State property. Why the taskless view and not the content view? Either would work, but invalidating the entire content view would be wasteful, as you don't need the button and text field to also invalidate. Okay. Oh, I see. Okay, so that could be, it's kind of the equivalent of, I mean, at this point, I don't know that you could consider it new, but I remember 2022 when I was first learning web dev, and islands was a big new hot thing. I think I want to say the Dino frame, Dino. Yeah, Dino, it's called Dino. Dino, the JavaScript runtime, Doll's second creation. It's pretty sick, actually. I use the service a little bit, the Dino deploy. But anyway, their framework, Fresh, it's a web framework. I'm pretty sure that introduced the concept of islands, or was the first one to do it that I had heard of. But just hydrating, or no, wait. It was either that or Remix. But effectively it was, let me see, actually it might be, here's a good example. If they still have it on their site, I can show you real quick. They made a pretty cool, I thought it was, no? Remix framework. But they had a homepage that showed you, yeah, okay, it looks, oh no, I'm thinking of nested routes, but it's kind of the same concept, but this ended up being a bit, it's not quite islands, but it gets the point across. So for example, like what the book is saying is if only, let's say this portion of the, I'm trying to scroll down. Yeah, it's designed to do this. So let me, I guess it won't do it unless I, oh, cool, there we go. Okay, so yeah, so it'd be wasteful, they're saying the content view would just be the root. Like that would just refresh the whole page. And so all the little things on all the data points basically on the page would have to rehydrate, i.e. make network calls, get the data again, compute whatever values we have in the code. But if you don't need to do that, then why not just refresh the invoices, like some subset of the data? So that's what they're saying. So some smaller portion of the total view can be refreshed without having to recompute and re-render everything on the screen. All right. So would be wasteful, as you don't need the button and text field to also invalidate. The task list view is the closest view to the list itself in the hierarchy that has a reference to the task store. Invalidating the task list view invalidates as little of your hierarchy as possible while still getting the desired effect, a list refresh. Yeah. Build and run. Okay. Command R. Finish big nerd guide. Hell yeah, brother. But this should go away. Damn. Okay. Build and run, trying a test this time. It should be added, and it was. Now you just need to clear the text from the text field when the button is tapped. Clearing the text. Content view, not Swift. Okay. And okay, we're there. So underneath the add, after the add, which makes sense. So after the action of adding the task, then we want to new task title, which is our property we marked with state up above. And so we're, oh, okay, I see. After we add it, we just change it back to an empty string, which makes sense. Okay. So let's try it again. The hell, I forgot my, oh, right. So each time I run it, it's going to go get that sample data, which does not include the one I just added. So try again, brother. Cool. Note that this assignment to new Note that this assignment to new task title will, as before, invalidate the content view, causing the button and text field to be redrawn, empty this time. The user can add tasks and see them populate in the list, which is great, but what should they do when a task is complete? Todoodle should let users delete tasks when they are done. Well, yeah. List of user editable content in iOS can allow the user to swipe across an item from right to left to reveal a delete button. Tapping it removes that item from the list. To support this swipe to delete behavior, add an onDelete modifier to the for each that feeds the list. Okay, where you at? Task list view. I'm gonna get rid of that for now. Okay, what do you want me to do? To the for each after task view title. Okay. And I get to the end with $. That's right. Okay. Task title. Oh no, wrong file. Content view. Okay. Task view title. Where the hell is that? Task view. Further down, maybe. This is content view. No, it's not. Task list view, right? Task list view. Yeah, okay. All right, now after the title, task.title. So following the for each, we call a method on it, on delete, which must be, if we go, I'm gonna go look real quick. I just want to see what it, really? Okay. I wanted to see the definition, but I guess not. But that's what it must be. So it's a method available on the list type, on delete is, and then we're using a closure with another nested closure to do this. So index set, which would be our argument in the closure. And then the function body, so index set for each. And then another closure index in, let task equal test store.task index I got this looking all funky. Okay, hold on. Index. Okay, so in the list, we get a for each iterating over the task. Task title, and then on delete, we run, I don't know what this is, index set, and index set for each. But we have this temporary constant, let task equal the okay. Let the temporary thing equal the index of the task currently being iterated over, and then remove that task using its index. Okay. All right. The onDelete modifier takes a closure to execute when a view emitted by the for each is deleted using the swipe to delete gesture. The onDelete modifier takes a closure to execute when a view emitted by the for each is deleted. Okay. So I should now be able to, oh, cool. Oh. Sweet. Congrats, Doodle is now nearly feature complete for iOS. There's one glaring omission. When the program quits, all your data is gone. The next time you launch the app, the sample data would be back. That's true. It happened to me. Saving and loading user data. The task store is not currently saving task to disk or loading save task on launch. It is time to fix that so you can relegate the sample data to the preview providers. To begin, you will need a file manager. The file manager type allows you to work with the contents of the file system, such as generating the local URL of a place where you can save data. Okay. The URL, Universal Resource Locator, by the way, the URL type is basically a specialized string that refers to the location of a resource, like a locally stored file or a document on the internet. Yeah. URL is a true... Well, I can't even say that. It is domain specific. Never mind. Well, the domain is there. Yeah, it's a true universal thing. Give the task store handy access to a local URL. Give the task store handy access to a local URL where it can store your to-do list. Okay. So task store Swift. Okay. Private observable. Oh, okay, above the main object. All right. So again, it's private, so it can't be modified by anything outside of, or it can't be initialized by anything outside of the class task store. File URL. It's of, oh, there's a type URL. Cool. Or maybe it's a protocol. And then we have a trailing closure. To initialize it. All right, brother. All right, let file manager equal file manager default. And this is file manager default and get mounted volume URL, including resource values for keys, options, returns a NS array. What is that NS stuff I keep seeing? Is that like a namespace or what does that mean? We will ask Grok about it. NS I see in some types, i.e., what did it say? Yeah, NS array, NS URL, NS array, NS URL. It's a reference to the Objective-C heritage of the Cocoa frameworks. The NS stands for next step, which was the operating system developed by Next, the company founded by Steve Jobs after he left Apple the first time. Oh, well, I should say the only time, voluntarily. When Apple acquired Next in '96, they used Next Step as the foundation for their own operating system. Oh, the NS prefix was carried over to the frameworks and classes that were part of the Next Step legacy. I see. That's interesting and good to know. So if I see NS, we can just think ancient. ancient. And hopefully, like, for example, I know if you, and this is something we'll do on this stream, because I think the misnomer for a while has been Swift isn't ready to be used outside of the Apple ecosystem, which isn't true. It's on Windows even, which is crazy, but you can definitely write, web apps with it, web servers, stuff like that. But when you do that, like when you're writing on Apple's platforms, you're getting I think it's the foundation. A lot of those frameworks come with it, which are coming from Objective-C. So it's just a lot bigger package that you're getting versus if you were to go install Swift on straight up Linux, you're not getting those frameworks. It's just the Swift standard library, which might not necessarily be a bad thing, but I guess we'll find out how easy it is to not interact or not have to worry about Objective-C. So hopefully that is minimal in terms of having to understand. But I'm pretty sure it is, because I did I was leery of that when I was doing research on Swift, and the consensus was, yeah, there's no dependency on Objective-C in that regard if you're writing a new application. Okay, so file manager default. Went down a rabbit hole for a sec. Let document directories equal file manager dot URLs for document directory. And in being another parameter name. And we would pass in user domain mask. What is all this stuff? Domain mask. Okay. Then another constant, my document directory is equal to document directories dot first. So we're force unwrapping and optional there with that trailing syntax. Okay. Is that? Yeah, it is an exclamation point. Okay, and then let task file URL equal my no space document directory. Pending path component. Sheesh. Task.json. I see. So we're just storing it in a local JSON file and then print task file is escape character and then pull in the URL to the local JSON file, task file URL. Yeah. Why doesn't it see it? Because I don't have an S over here. Task. Yeah. And then return. Return task file URL. And initialize. Okay, so what's cracking? Private constant variable named file URL of type URL. Or is this a value that identifies the location of a resource, such as an item? Yeah, okay, it is a type. Server. You can construct URLs and access their parts For URLs that represent local files, you can also manipulate properties of those files directly, such as changing the file's last modification date. Oh, that's beautiful. Yeah, I don't know that it's the best approach, but in Go, I was constantly doing this just as a way to, if you're moving data from server to server and you have multiple transforms, I would just use that to effectively mark what had been processed. And then you can build rules around, if modification date is, more than 90 minutes old, because it gives you all the way down to the, date, hour, minute, seconds. You get a timestamp. So you can say if X amount of time has elapsed, go check on this data source and refresh if need be. So that's cool. So yeah, ways to easily work with the file system, especially the metadata of files, is always a big help. Finally, you can pass URLs to other APIs to retrieve the contents of those URLs. Awesome. For example, you can use URL session and its related classes to access the contents of remote resources. URLs are the preferred way to refer to local files. Most objects that read data from or write data to a file have methods that accept a URL instead of a path name as the file reference. For example, you can get the contents of a local file URL as string by calling this initializer init contents of encoding, or as a data by calling init contents of options. Okay, as a convenience, you can use Swift's async await syntax to asynchronously access the content of a URL through the resource bytes and lines properties. I did not know it already had async await. I guess it'd have to if you're writing web servers. Okay, these properties use the shared URL session instance to load the resource. Use the shared URLs. Meaning what? It can share like over one WebSocket? I'm not sure what they mean. Sounds neat though. I guess we'll figure it out later. Okay, so return task file URL. You get a reference to the default file manager from the Foundation framework. Oh, that's where that's coming from. Okay. Which is used for working with locations and directories in the file system in all kinds of apps, including command line apps. Yeah. Okay. In all kinds of, okay. You can use a file manager to create, move, delete, and learn about files and directories. You could create your own instance, but there is generally no need to, since there is a default instance available. Next, you call the URLs for in method of the file manager. Next, you call the URLs for in method. For in. Yeah, just show me, brother. Let's just look at it real quick. It being the URL type, so it's a struct, so it's a value type. It's conforming to reference convertible, equatable, and sendable, which sendable and reference convertible we've not encountered yet. Equatable just means it implements, the compiler will implement the equality check. So this, oops. Oh yeah, I can't edit this. The double equal sign, the equality operator. Just by conforming, the compiler will implement the equality operator and the less than operator. All right, so then 3 type aliases in this URL, bookmark creation. Public init. So 2 different or a few different initializers. So we can do it with a string. It could even be nil, I suppose, since it's marked as optional. Returns nil if a URL cannot be formed with the string. Oh, okay. So if we pass it a string and it doesn't form a valid URL, then it will return nil. For example, if the string contains characters that are illegal in a URL or is an empty string. And then this one, public init. And we can pass a string and a relative to. Oh, it's like give it a partial if we want to. Yeah, so if we don't necessarily have the absolute path, like in a Docker image, but you always know where the root will be, maybe. Returns nil if a URL cannot be formed with a string. For example, if the string contains characters that are illegal or is an empty string. Why is it? That's literally the same. Is it describing what's above it or below it? Let's see. Initialize with string. Returns nil. No, it's what's below it, yeah. Initialize with string relative to another URL. Okay, so I guess that's just implied. Let's see. Initialize with a URL string and the option to add or skip IDNA and percent encoding. IDNA. Hold on. What is IDNA in this context of Swift? IDNA stands for Internationalized Domain Names in Applications. It's a standard that allows for the representation of internationalized domain names, IDNs, which can include characters from a wide range of languages using only the ASCII character set. I see. In the context of Swift, the URL initializer you mentioned allows you to control whether IDNA and percent encoding is applied to invalid characters in the URL string. If encoding invalid characters is set to true, the URL initializer will try to encode invalid characters to make the URL valid. If it's set to false, the initializer will turn nil. If the URL string is invalid, according to RFC 3986, which defines the generic universal resource identifier syntax. Okay. Always a standard, eh? Good old acronyms. Okay, well then, now we can go back. That makes enough sense. Next, you call the URLs. Wait, my bad. Where were we? Test or here. Okay. Next, you call the URLs for in, which is here. So, or rather here. So we're using this to give document directories a value. All right, so we call URLs for in method of the file manager to look up a list of document directories that you can access. So based off the file manager's implementation, we can call this method from that type file manager. And we're saying for whatever the document directory is in whatever domain that you're in. And it gives us what? To look up a list of document directories that you can access based off of, I assume based off of your user, I mean whoever you're logged into in terms of the operating system itself. It's like in my case, it would look and see whatever my user is, indog or whatever. Yeah, it would just look and see what are the permissions for indog on this server, my local laptop, and then give that list back, which hopefully is everything, I would hope. You can use a file manager to, where'd it go? Which we're giving. Oh, my bad. Okay, there we go. This method is designed to search for different locations from system-owned temporary directories to user-owned document directories. The .document directory case of the file manager .search path directory enum. That's a mouthful. The .document directory case. Oh, the case statement in the enum. Yeah. Of the file manager .search path directory enum specifies that you want a directory appropriate for storing documents as opposed to other types of files such as caches or temporary files. Okay, but where the document directory case of the file manager.search path directory? Where is that? Can we see that? Okay, there it is. So there's the case, and what is this the, oh, okay, there's the enum. So this is from the foundation framework. There's this enum, and it's, oh, I see. Okay, so file manager dot search path directory, which is what they're saying. Okay, so it's a nested type. That keeps throwing me off. I need to remember that that's a thing, because every time I see the dot, I think method, but that's not necessarily the case. Okay, so search path directory enum specifies you want a directory appropriate for storing documents. And document directory. So this thing equals 9. So how does that? That must be an option somewhere. So if this is 9, and that somehow tells it all of that, then maybe further in this extension, there's got to be somewhere where they map the numeric code to that behavior. Now where might that be, brother? Maybe if I GD this. What's super sick that I'm already seeing is this available, and they can name the version specifically, like where it's available. What a blessing. That's awesome. We struggle with that hard. And I often wonder how much of it, you know, because back in the day when I was just writing SQL, I really didn't have any understanding of these programming concepts, you know, outside of the realm of just databases. And I can remember a lot of issues that were tied to versioning, like all the time. They were using FoxPro and having conversations with the developer. And, you know, there was a bit of a language barrier. She was Israeli. She was the primary. Other people worked on it, but it was mainly her. And she didn't really understand, you know, systems, like just computers in general, hard disk, or even servers or networking. She was like just a FoxPro dev. And so I often wonder, and she was self-taught too. Nothing wrong with self-taught. I'm self-taught. But it's just, it's a curious thing, because you often wonder, like, these are all things from Objective-C, which that predated FoxPro. So I would imagine stuff like this probably was available. She just, you know, you're effectively at the mercy of the developer, you don't necessarily know. And if you don't even know enough to go and look for additional, solutions, then, you're just at the mercy of the amount of code they know for the given language. So it's kind of it's an interesting thought. But yeah, I mean, if nothing else, I think it's always I think any dev worth their salt can stand up to any level of critiques, I'll say. So don't ever be afraid to question a dev, because yeah, it really shouldn't be taken in a negative light, to be honest. Okay, anyway, where was I was trying to find where that mapped to, but I guess it's not important, so we can get back to it. So you're foreign file manager. Okay, here we were. The .document directory case of the file manager search path directory enum specifies that you want a directory appropriate for storing documents. So as far as we know, like just right now, this description somehow equates to document directory having a value of 9, and that value of 9 maps to this behavior somewhere. So there's probably like a filtered list to only accept or to not accept files with extensions that represent caches of temporary files, maybe .tmp. The user domain mask case of the file manager search domain mask. The user domain mask case of the file manager search domain mask enum tells the file manager to look within the user's home folder. User domain mask case of the file manager. So look within the user's home folder. Okay. So, oh, I see. So we're saying for that filtering of document types inside of user domain mask, which is the home folder. Okay. And then the return value of URLs for in is an array of URL instances representing the location of local directories where you can store and retrieve data. Okay, so this thing returns an array of URLs, which gets stored in our constant bucket document directories. It never dawned on me until now, but I guess that's why, if you're like, if you have a file explorer window open into some directory, like for me, my directory where I store, like when I'm streaming, it's automatically writing a local recording of the stream to this particular directory. But if I already have it open, that same directory, if I already have it open before I start the stream, when I end the stream, it doesn't show up there until I, refresh or close the window, come back. Which makes sense now because this is it's a constant. So it can't, within that instance, can't change the values that are there. You have to kill it, call it again, make a new one. It's just interesting how that lines up, but I wonder why. Well, whatever, it doesn't matter. But the number of directories returned. Okay, the return value for URLs foreign is an array of URL instances representing the location of local directories where you can store and retrieve data. The number of directories returned by URLs foreign depends on its arguments. Since you are searching the .document directory in the user domain mask, there will be exactly one object. Pardon me. There will be exactly one object in the returned array. Why? Since you were searching for the in the user domain mask, it would be exactly one object, which would be the home directory. Is that what we're saying? Finally, you append the task.json path component to the URL so that the final resulting URL represents the location on disk where you will save and load the task. Finally, you append the task.json path component. Oh, I see. So up to this point, we get the home folder. Like, so this would be like whatever the file path is on a Mac to your home directory, and then we create this task JSON. And so by using these two, it'll always be the same for every user, because we can, via the file manager, get the home directory. We know the user's name, or the username. So we can build that portion of the path here, because that's not going to change across. Well, I mean, this will change, but we know what that is. So we know the variable to pull that in. And then we just append task.json to that, and that's our file. Okay. Yeah, that makes sense to me. So we append it and then print task file is, and then we print the full path. And then return it and do other junk with it. Okay. Finally, append the task. Finally, you append the task.json path component to the URL so that the final resulting URL represents the location on disk where you will save and load the task. I have the hiccups. Why? You are going to store content in the JSON file format. Damn it. Which is a more popular text file format for data storage. I fucking hate JSON, dude. I really hate JSON. You're going to store content in the JSON file format, which is a popular text file format for data storage and transmission. Why? Got me, brother. Details of JSON are out of scope for this book, but you can find a great summary on Wikipedia. Yeah, no, I'm good. JavaScript is just a subset of, JSON is just a subset of JavaScript. So that should tell you. But now that the task store knows where to store the task, you can teach it how to store them. Now that the task store knows where to store the tasks, you can teach it how to store them. Implement a save task method. Okay. In the task store again. Yep. Private func save task. Okay. Do let. I thought we. Okay, I'll have to ask that then. I thought we couldn't do or use do catch blocks without try, but maybe that's only functions. Let encoder equal JSON encoder. Oh, nice. Warning. Finish implementing encoding work. Okay, and then catch print could not save. So if it fails and we get an error to the console, we print could not save task. Reason. And escape character, and then we pull in the error value. Okay. Command, is it Command Shift Y? Yeah. Okay. Catch, print. Here you create an instance of JSON encoder, a type that can encode instances of various types into instances of data using its throwing encode method. Yeah, it should be working. Let me see if this will work. GPT. Why are we able to use do catch blocks in without a I think it's Shift Enter. No, not working. Yeah, why isn't it working? Probably because of Xcode. This is pretty cool. It's well, it's supposed to. I mean, when it works, it's pretty cool. But let's try in Bear. It's supposed to let you give it a little shortcut like so, and then you type it in, and it doesn't work. Okay, cool, sweet, awesome. Maybe. Guess I gotta change my key anyway since I'm streaming it, but GPT, hello. Oh, it worked. Okay. Same line, maybe? That's probably why. Now I gotta retype that. God damn it. Okay. This. Get rid of this. Enter GPT. Pa. Isn't that sick? I mean, it took a little ceremony, but that's the first time it hadn't really. But yeah, if you like that, as far as I can tell, it works anywhere that's using. That's a native app, basically, a native macOS app. I'm not sure if it'll work in browsers like hi. Well, okay, shit. Like in a URL bar, that wouldn't make sense, but hello. Well, whatever, it really doesn't matter, but I want to see what it says. Okay, so this is the best Node app, by the way, hands down. Catch blocks. If a function can throw an error, it must be marked with the throws keyword. When you call a function that can throw an error, you prefix the call with try. However, in SwiftUI, you might be using APIs that. Okay, that is why. So we can do it in the context of SwiftUI because it's handling it for you. But we learned in Swift that you can't. Oh, yeah, I don't like that, but okay. I guess they're making it easier or whatever, but if it's a framework for the language, maybe follow the language's rules, but That's fine nonetheless, but usually we would have to do, I think it's throws, yeah. In the do block. And then here we would have to do try. No calls to throwing functions. Hold on. Now I need to see it. Code. Throws. Rethrows. Throw an exception. Catch all. Okay, so here's an example. Func. So the arguments first. Throws. If. Yeah, do, try. Oh, we have to. Maybe that's why. I just want to see what it looks like written quote unquote correctly, but oh well, whatever. I will just, is this how it was? Let encoder. No errors are thrown. Do catch, print, could not save. Trying to get it to go back to what it was doing. JSON encoder. That error should go away. Let's just rebuild it. Why are you texting me? Huh? No, I know. I said, why are you texting me? Oh, thanks, baby. Sorry, I beaked you. Yeah, it is hot. It's fucking hot, dude. Won't catch me outside. That's not true. I was outside yesterday and just fucking melting. It's hot as shit. It's been raining. It's unbelievably humid. But we get by. We get by. All right. So why the fuck is it doing this? Unreachable because no errors. Yeah, but I didn't. All I did was change it back, man. I don't think it was doing that before. Oh well. We will come back to that. Because I'm done with you. Okay, private func save task do. That is exactly what I have. Here you create an instance of JSON encoder, a type that can encode instances of various types into instances of data. Oh shit, I forgot. This is what I meant to do. I just want to see this. In the context of not in SwiftUI. Please rewrite this using throw and try. Okay, that's not what I expected. So let encoder equal try encoder dot encode. Oh, so we're not, okay, we're not. It's because this isn't, or this isn't a function. That is, what are you? It's a class. Okay. Well, that makes sense. But I do want to know why, or is not what I expected. When would be appropriate? Use the throws keyword in the function signature. That's what I was expecting. Okay. Or at least the shape of what I was expecting. The throws keyword in Swift is used in the context of error handling to indicate that a function or method can potentially throw an error. Which this is. Yeah, this is a method. This is a method on, yeah, on a task store. Okay. It's appropriate to use the throws keyword in the function signature when you want to indicate that the function can encounter conditions that might lead to an error. This allows the caller of the function to prepare to handle any potential errors that might occur. For example, if you're writing a function that performs a division operation, you might want to throw an error if the divisor is 0. Okay, yeah. In this case, you would use the throws keyword in the function signature to indicate that the function can throw an error in such a situation. Okay, but that's clearly they're two different implementations, but so what am I trying to ask here? I guess the real question is, I thought do catch was tied to the throws, so there's marked with throws. How about this? Are there any restrictions in Swift that are not present in SwiftUI around the use of throws and do catch blocks? My confusion stems from seeing do catch in the original sample provided without seeing the throws in the function signature. When you call a function that is marked with the throws keyword, you need to use the try keyword or handle the error using, okay. You need to use the try keyword or handle the error using a do catch block. Okay. This allows you to handle any potential errors that might occur when calling the function. In SwiftUI, you can also use the try and do catch keywords in the same way. There are no specific restrictions. Okay, the confusion in the original sample you provided might be due to the fact that the save task function is not marked with the throws keyword. Is that the Right. Yeah, that's right. That is the confusion. Okay. Is not marked with the throws keyword, but it uses a do catch block. In this case, the do catch block is used to catch and handle any errors that might occur within the block, but it doesn't rethrow the error. Rethrow the error. If the save task function were to throw an error and it was marked with the throws keyword, the caller of the function would need to use the try keyword or handle the error using a do catch. Okay. In this case, the do catch block is used to catch and handle, but doesn't rethrow. I don't know that we covered any kind of rethrowing, so okay. So it won't rethrow, but somehow we still, oh, I guess because we don't have to rethrow because on error we just send it to standard out and then that's it. But maybe if we wanted to handle the error and do something else to it, so if we needed to get it outside the scope of the function, then we would want it to rethrow. Let me look because it doesn't feel right going forward when this makes 0 sense to me. Rethrow on R. I really don't remember seeing, I mean, we saw it in other examples, but I don't remember anything in terms of direct content addressing what that does, rethrow. Yeah, it's not even a term here, which is okay. You can just have them explain it to us, but because it kind of sounds like we know what that means now just by that explanation. Lexing an input string, throws. Oh, so there's throw and throws. Yeah, goddamn. Okay. Throws. The computer science. Goddamn itch. Sequence a token. Where do we see that? Okay, I didn't even see it. Throws. Add the keyword throws after the parentheses. Okay, so this is where we first saw it. After the parentheses containing the arguments, the implementation of Lex is incomplete. And yeah. Let's see. If this case matches, then a character you were not expecting is next. That means you need to throw an error. In Swift, you use the throws keyword to send or throw an error back to the caller. Okay. So in this case, we're not sending an error back to the caller. That helps. What can you throw? You must throw an instance of a type that conforms to the error protocol. Okay. Okay. One option would be Lex or error. Okay, so maybe I can ask a better question now. So if we take... So take the whole class. And oh wait, can I use my? We'll just ask Grok again. How do I get a new? There we go. In the below SwiftLang class. What do I want to say here? Save task. What would be the reasoning for not using throws in the what was it called? Save. Damn it. Save list. Save task. In the save task function. Would be implications of not and only using a do catch block. How about that? Okay. The reasoning for not using throws in the save task function is likely to avoid propagating the error up the call stack and instead handle it within the function itself. By using a do catch block, the function can catch any potential errors that occur during the saving process, e.g. Wait, what? The function... Oh, that occurred during the saving process. Example, JSON encoding errors, okay, and handle them gracefully without requiring the caller to handle the error. The implication of not using throws is that the function's caller will not be informed of the error, and the function will continue to execute even if an error occurs. Okay. Okay. Well, that makes a big difference. Okay. This may be acceptable in some scenarios where the caller does not need to know about the error or cannot handle it effectively. However, in other cases, it might be more appropriate to use throws and propagate the error up the call stack. This allows the caller to handle the error in a way that is specific to the context of the app, such as displaying an error message to the user or retrying the operation. Okay. I see. Okay, so we're handling it, but we don't stop the world if there's an error, so we can continue processing. That's good enough for me for now. It makes some sense, and that is enough sense. Okay, so now what page was I on? 812. There's no way. 781. Nah, come on. Shameless plugs, yeah. Okay, it's here. Teach it how. Okay, we did that. All right. Here you create an instance of JSON encoder, a type that can encode instances of various types into instances of data using its throwing encode method. Where? That encode. a type that can encode instances of various types into instances of data using its throwing encode method. Data is a type that encapsulates arbitrary chunks of type agnostic data. Just as, is a type that encapsulates arbitrary chunks of type agnostic data, just a pile of ones and zeros. Okay. When you are transferring data to the disk or across the network, the APIs that handle the transmission generally do not care how your information is encoded. It is up to the saving and loading code or transmitting and receiving code to agree on how to interpret and translate the contents of an instance of data. You are using JSON, but there are other formats available. Yeah. Like gRPC. What types can Parquet? What types can JSON encoder work with? Any type that conforms to Swift's encodable protocol. Okay, I see further now we're adding a try at least, so I guess the throws is defined elsewhere, but it is there on the encoder. I mean, that has to be what it's doing. JSON encoder. Type alias. It's probably on one of these other protocols, but okay, fine. I will. Yeah, because where does this one? What was the trick? Percent sign? There. There it is. Okay. Damn, it's huge. Wait. Percent. Oh, 14654 to 14809. Okay. All right, but this is, yeah, so here it is. So the encoder and these all throw. So that's why we can call try, and it's just coming through. See that gosh darn inheritance. That's the thing though, like in Go, you would have to, all of this stuff is, like I can see how this would be advantageous for moving quickly after you learn all these APIs. In Go, it's more like you wouldn't necessarily get all this convenience, but it makes it really simple to just on the fly you're writing these things. Yeah, so just a different approach, I suppose. But at least I found, I mean, it makes sense now based off what we've learned about the language. So that's good enough for me. So then, where is the any types that here to encodable? Okay, where were we? That means the task type must be encodable. You will also want to decode instances of data back into an array of tasks. That process will require tasks to conform to the decodable protocol. So to support both encoding and decoding, tasks will need to be both encodable and decodable. To save you some typing, Swift defines a protocol composition which you learned about in chapter 19 of encodable and decodable called simply codable. Make tasks conform to codable. Okay, struct task. Identifiable, and now codable. Okay, as with equatable and hashable, the compiler is willing to synthesize the codable protocol requirements for most value types. As with equatable and hashable, the compiler is willing to synthesize the codable protocol requirements for most value types. Oh, okay, meaning we don't have to manually add the properties or methods required to the type, it'll do that for you simply by marking it as conforming, like we did here. As long as all non-lazy stored properties are also codable. Okay, the compiler will also synthesize, try not to yawn, codable conformance for classes that meet the same requirement. The compiler will also synthesize codable conformance for classes that meet the same requirement. Okay. Nearly all the basic types in the Swift standard library, from int to URL and data, what is she sending me? There's this freaking demon cat that's what she's stalking me in this this little gated community that I'm in. I don't know what its problem is, brother, but I ain't done shit to that cat. Okay, so equatable. Nearly all the basic types. Like I swear, when I'm leaving, if I'm walking around here, I never see him. Like directly in front of me. But every now and then, it's happened at least for sure 3 times, maybe like 5. I've been walking in, and I'll just feel like a presence on me. And I'll turn around, and I'll see that fucking cat, and then he'll hide real quick. Like, oh shoot. Demon cat, man. And it's an orange cat. Of course it's an orange cat. Alright, as with equatable, nearly all the basic types conform. Yeah. And the collection types. Okay, here. Nearly all the basic types in the Swift standard library, from int to URL and data, conform to codable. And collection types like array are codable as long as their element types are. Okay. Return to the task store and finish encoding and saving data. Save on labor. Save task store. Okay, we're going to get rid of our warning because now we're going to implement it. Get the hell out of here. Let encoder. Let data. Let data equal try encoder. Encode task. And then try data.write to file URL. Okay, so now we're saying do this, catch that. So do let encoder equal an instance of the JSON encoder, and data will equal an attempt to encode the list of tasks. And then provided that works, we then take the data and try to write it to the file path, which would be the task.json in our home folder. So that makes sense. Let's see. Here you ask the encoder to encode. Yeah, I put some meat in the bottom there. I put some meat in that bottom drawer. Can you see which one you want to use? And just freeze the rest. Because they didn't have skirt steak. They had some other white folk version of it, though. No offense, white people. I'm just saying, y'all don't call it skirt steak, but it looked a lot like skirt steak. Kroger is super white though. They got that Nolan Ryan beef. even though I love Nolan Ryan. You young kids probably don't even know who that is, but okay. Private func load oh, right. Okay. Here you ask the encoder to encode your array of tasks into an instance of data. Then you write the encoded data to disk at the location specified by your file. Yeah. Okay. So data is just equal to the encodings. Then we try to write it. Okay. Both encode and write to can fail for reasons related to disk permissions or corrupt data. Hence the try. Yeah, and they will throw errors if they cannot finish their work. A more robust application would visually notify the app's users that the save had failed, but for your purposes, a message log to the console is enough. Right. Now implement a load task method. Is that okay? Yeah, here. So private func load task. Open that up. And then our do block. This makes a lot more sense now. Okay, that's way better. Okay, so do let data go try data as a type. Keep being crooked. Try data. Contents of file URL. Let decoder equal an instance of JSON decoder. JSON, yeah. JSON decoder. Then our task array, we'll try decoder dot decode the array of task. And then self to reference, or self-referencing instance, self-referential instance. We want to act on the instance itself. Therefore, we use self from data. Okay, so task is equal to a decoding of the array of task from our data. Makes sense. Print loaded. Loaded. Task.count. Oh, okay, so loaded X task from our path. URL path. Catch. Print. Did not load a task. Reason. Whatever the error is. Okay. You create a new instance of data here with the contents of the file, which is this, located at the URL. Then we create an instance of the decoder, put that in the decoder bucket, and use it to decode that data into an array of task instances, which is what we're doing here. Okay, just use to decode data into an array of task instances which you store in the task store's task property. Right. So this up here we have oh, I'm thinking of, my bad, thinking of task list, but that's where it's at. Okay. Okay, so that makes sense. So task, try decoding it, and if it works, then it'll be the array, the updated array, based off our file and what we were able to successfully decode. Okay. You create a new, wait, I read that already. Where am I at? JSON, which you store. Since the data type does not know anything about the kind of data it contains, the decode from method, decode from method of the JSON decoder must be told how to interpret the contents of the data. Okay. If the data contains the wrong kind of information, such as an array of integers instead of an array of tasks. Oh, I see. So it's checking. Or we're saying this is the type of data that you should expect. Okay. And then since it already conforms to codable, it would know what to do. Yeah, okay. If the data contains the wrong kind of information, such as an array of integers instead of an array of tasks, decode will throw an error. The task store is now capable of saving and loading tasks. Update the add and remove method to save changes when they are made. Hot dog, okay. Your task store is almost complete. It can now save and load tasks on behalf of the user. When the user launches Todoodle, you should load their saved task instead of the sample data. Start by loading any task that may be stored when an instance of task store is initialized. Wait, when it launches, it should load our saved task. Okay. Yeah. Task store. Or no, I'm already here. So where do you want? Under published. So now we're adding our own little custom initializer. Load task. So now when we initialize the task store, it will initialize by calling load task, okay, then that's here, which is what we just wrote. Okay. Gotcha. Cool, because the data would be in the home directory task.json. Nice. All right, the last step is to create a new instance of task store rather than using the sample data when the app launches. Update Todoodle app to create a new task store and pass it to the content view in place of taskstore.sample. Word up, brother. Swift app. Instead of sample here. We now want our task store. Let task. Oh, my bad. I was like, what's going on? Okay, let task store equal task store. This used to kill me. I used to just see this over and over. I'm like, why is it constantly, like, why are we repeating things so much? You know, task store equal task store. Self equals self, if self, elf, you know, all that shit. But now I get it. The whole concept of defining a thing and then creating an instance of the thing was just so foreign to me. Which is why I think myself and a lot of people in general, but certainly for me because of my background in SQL, I was just more drawn to the functional languages actually made more sense to me just because it just does a thing. There's no like object inheritance, property, you know, all that shit. But yeah, just wanted to say that out loud. All right, so we build and run the app. All right, build and run the app, build and run the app. And it will all be, there it is, brother. $1 million app. The list will be empty since you're not using the sample data. Add a few tasks of your own, then quit simulator and relaunch your app from Xcode. Your task should load up for you. Okay. I am. I was. I will be. Can still delete. All right. And then what? You want me to kill it? Relaunch your app from Xcode. Oh, and quit simulator. Okay. So quit it. And run again. Hot bibbity. All right. Congratulations. You've now built a functioning task list app for iOS. But what about macOS? Supporting macOS. The great news is that as of macOS Big Sur, a single SwiftUI app can be deployed to both iOS and macOS. That is pretty sick. From the scheme selector at the top of Xcode's window, switch to the Todoodle macOS scheme, build and run, and Todoodle will launch party will launch on your app. Only the real ones will know what I'm talking about. Okay, so you want me to kill this, brother, and then change what? Todoodle. Oh. Yeah. My Mac. Build and run that bad boy. That is just neat. You can imagine, I mean, obviously we're still learning, but to get an app up and running, I mean, that's, you know, it's not heaven and earth. You can move pretty quickly. Yeah, that is encouraging, I'll say. Cool. All right, so then what? Unsurprisingly, developing for macOS introduces specific concerns and interaction paradigms. My mouth be dry. And interaction paradigms that you should take into account. For example, apps can create different windows of different sizes. As with any app development project, you would want to work with your users and a designer to help you identify the ideal sizes of interface elements. For now, add some constraints to the window size when the app is running on macOS. Okay. Inside of the window group, you say. And then if OS macOS content view, and these modifiers are really cool. I like this a lot. Probably my favorite thing about SwiftUI, min width, because I mean, I guess mostly because it's just like CSS, or very similar. Max width is 300. Wait, are there no, there's commas. Yeah. Min height. $200. Else. Content view. Task store. End of. Unknown operating system for build config OS. Did I not capitalize? Or I did not capitalize. Okay. First, you separate your code into two different versions, one for macOS and one for everything else. Everything else, air quotes, really just means iOS in this case, since this app is only capable of running on macOS and iOS. Fair enough. You use the if compiler control statement to ensure that the lines up to the subsequent else statement are only compiled when building for macOS. So our, wait, what? Yeah, here. Okay. Lines between the else and endif statements will only be included when you are building for a different OS, which in this case would be iOS. Okay. Yeah, and so on build, we would choose the target. And so if it's macOS, it'll apply this. If it ain't, regular old iOS. Okay. In the macOS only block, you add a frame modifier to specify constraints on the size of the window. The modifier accepts lots of arguments for size restrictions, but you only need to include the ones you want to deviate from the default. Build and run on macOS again, and you'll see that the window is smaller. Okay. Yeah, there's some apps where clearly they're not doing this, and it's really annoying. Or rather, I should say they're doing this, but they're not doing it right, or not in a way that makes sense, and then you can't do anything with their window, and it's really fucking annoying. Another difference between iOS and macOS is that the macOS does not natively use swipe to delete to remove rows from list. Ah, right, can't do that. Try as you might, you will find that you cannot delete a row from Todoodle in macOS. Add a right-click context menu with a delete option to each task view created for the list. Okay, task view list. Task view. Where the hell is that? Oh, this title, test.title. Okay, there you are. Dot. Context menu. Button. Delete. Task store dot remove task. Cool. Just like that, huh? Okay, so we test for task. So inside this closure for the for each. Okay. So for all of these tasks, we're saying add this modifier, which adds the delete button. Okay. Build. The context menu modifier accepts a view builder closure containing views that will be used as the menu options for a right click or long press on iOS contextual menu. Build and run, add a task, then right click it to show the context menu. Hell yeah, brother. Get out. Client error. TU, the remote view does not override and thus cannot react to catastrophic errors beyond logging them. Okay. We had, yeah, that worked. And there you have it, your shiny new SwiftUI taskless app that works on both macOS and iOS. There are a lot of other features you could add and glitches you could fix. For example, if you open multiple windows on macOS, they edit the same task store. But all that can come later. For now, take a deep breath, be proud of your accomplishments. And add one more task to Todoodle. Keep learning. That's right, brother. And we are, so keep learning. Oh, didn't add it. There we go. Keep learning. We're not gonna do these challenges. I got my own challenges, brother. You're gonna give me extra stuff. Congrats. You finished this intro to the Swift programming language. Thank you for sticking with us. Along the way, you covered quite a bit of material, from the basic features of Swift, like let and var, to more advanced features like generics and property wrappers. You also saw how to put these pieces together to write complete Swift programs, and you applied your understanding of Swift to write some simple macOS and iOS apps. You are now a Swift developer. Probably not a very good one. Yeah, but that is okay. It will change with time, practice, and continued learning. Definitely not a very good one. Where to go from here? After all your hard work, what should you do next? The truth is that your journey is just beginning. Swift is a rich language. There is ample opportunity to learn more every day. Swift can be used to develop for any of Apple's platforms using their respective UI frameworks, or even to develop server-side applications. Studying these frameworks for your platform of choice should be your next step. May we make a recommendation? Please do. Shameless plugs. If you want to develop iOS apps, we have a book that is a natural follow-up to this one, iOS Programming. Big Nerd Ranch Guide. Yeah, I mean, go figure. That is the book that I keep talking about. So we will be we'll be acting on their recommendation. If you enjoyed this book and want to learn more about Android or web dev, please take a look. Yeah, y'all really should. Just go check it out, because if you have any other domains that you want to learn that aren't Swift or, relative to the stream, these are really good books. I've said it before, I'll say it again. Matter of fact, I'll show you again, but I mean, it doesn't matter. I have hundreds of programming books. I've had a big, I'll say a bigger sample size than most, and these are easily, I think the Big Nerd Ranch guides, just in terms of the teaching style and the quality of the book, irregardless of the topic. I think Big Nerd Ranch and the, what are they called? It's Manning.com. These live projects, these two are probably the best that I've encountered in terms of like just quality of education out there, for published literature. The live projects are a bit more interactive, but I mean, in both cases, you're getting actual experience building something. So yeah, those are my recommendations too. So check those out. An invitation to the community. Make something new. If you do not have a project in mind, visit developer.apple.com. Provides a good overview of resources available. Okay, let me bookmark that bad boy. And bring it over here. If you don't use Edge, by the way, you're missing out, brother. It's like Chrome, but better. And then let's see. Now, you want to know why? Because I can do this. Bam. Can you do that? Does your browser do that? Then I can switch it like this. Huh? Come on. And I can do this. See my tabs? Vertical tabs, baby. And that's just scratching the surface, but no, it's a good browser. It takes a while to turn all the bullshit off, but once you get Bing turned off and all the bullshit settings, it's good. Okay, so and all the Chrome extensions work because they're both just Chromium under the hood. But yeah. All right, now what else? Consider finding meetup groups. Oh, brother, I'm the meetup group. Also, we love your feedback. Okay, that's it, y'all. We've done it. Success. Let's see, what are we at? 2 hours. Okay, yeah, so we'll call it there. I think. Oh, wait. I just wanted to show you. I just want to dink around real quick, not for too long, but there was a. Let me see. I kept it in a folder. WAPs, writing apps, creative apps, developer apps. It should be in here. There was one in particular, or two. There was one that had, it's either this or Details Pro. So we'll try this one first. Yeah, okay, so this one, list every single element in SwiftUI, right? Buttons and links, menus, value inputs, pickers, indicators, images. So all the elements. And it shows you examples that way you can kind of understand what the different settings do. And not only that, see, this is super sick. Look at all the shapes that are built in. You can mess with the settings to see what that will look like. Add modifiers. This is make my little color thingy here. It did cost money, but anything worth your while likely will, or time, or both. But method, line, I mean, this is pretty cool, right? We all agree. And the best part is it's not just the examples. So you have easy access to the docs. It just pops up right there, which is, come on, that's kind of beautiful. It's pretty damn beautiful. And it's the official docs, not some some guy's version of it, not my version of it. So this is really sweet. And then you can also see the examples. So for a rectangle, you got code samples. Isn't that sick? I mean, it's kind of crazy. So, I mean, huge nuts to whoever built this thing. But yeah, this is incredible. So we're going to use this a lot. And it makes a lot more sense now that I have looked at it before. I didn't know what the hell I was looking at before, but yeah, this is incredible. So there's this thing, right? And then there's also, I think the other one is more of a builder, like an actual thing you can use to generate code and then push it directly into your project, which was, yeah, I want to say Details Pro. Yeah, so this one's like an actual drag and drop building designs, and it uses SwiftUI. So, but I mean, I have no idea how to use it. So yeah, we won't dig too deep. The other one is really what I wanted to show you, because I think, even though, I mean, this is nice and all, this to me is just a godsend, because there's nothing better than like not only the raw knowledge, but having the docs at your fingertips and code samples and having visuals to see how your changes are gonna come out. So yeah, we're gonna live in this thing, or it'll stay open 24/7. But yeah, anyway, guys, we're gonna wrap it up there for today. Thank you guys for tuning in. Make sure you check in tomorrow. We will be back tomorrow, 11 a.m. per usual. And also check out my other stream, 9 p.m. Central Standard Time. My Halo stream, 100 Days of Ranked Halo. Road to Onyx, baby. Okay, so take care of yourself. Go get something to eat. Hydrate. See you next time.